Hey y'all, Data Guy here, and today I am back with yet another best practices video and also a viewer request video talking specifically about AWS Glue. So showing you a number of different workflows and practical examples for running number one, just a Glue environment locally so you can test and develop locally, but also show you a number of different implementations for how you can, implement Scala or Spark, serverless Spark, and then also more debugging workflows, figuring out and handling memory issues, and also how you can set up monitoring and observability integrations with something like CloudWatch so you can have a real-time monitoring dashboard on your AWS Glue activities, and then going into some of the performance optimization strategies or error handling and retry strategies you can use for even further examples of ways you can automate and have your Glue run really seamlessly, and when it doesn't, tell you exactly where something broke and exactly what you might need to do to fix it. So without further ado, let's get into it. If you like these videos, please like, subscribe, consider joining my Patreon, but let's start coding. So first of all, if you want to just try running Glue on your local machine, you can. You can actually download the Glue image from AWS and then run it on Docker on your own machine. It's not going to be able to find it locally. Then it's going to pull it from the online public Glue repository and then let me run it on my own local environment. So that's what I'm going to do for today, just to make it easier to actually show you how to build these scripts and just run them all locally. So if we then wait for this to download and cut back in once it's done downloading. So once it's done, you'll see you have a little Spark terminal to turn up, and now I have a local environment that I can run any scripts that I want to build here with. And so I'll just first, show you, hey, how you would implement basic PySpark script using, Glue. So pretty much just the same as any Spark script, and I won't spend too much time on this, more as an example file that we can use for then some of the downstream workflows I'll show you for optimizing it. But let's say I just wanted to have a basic etl.py, and then I'm just going to import a basic PySpark script where I'm just going to be importing the usual set of PySpark packages, and then AWS Glue, Glue context, the Glue specific version of a lot of those packages, right? So a Glue job, resolved options, transforms, all the different functions for transforming. Then creating all my context, so creating Glue context, Spark context, so I'm able to get the context of the job that's where it's actually running within that Spark environment. So even though I'm running on a local machine, this will also work, if you're running it in the cloud, getting the context and the errors that are specific to that environment. And here I'm just running a pretty typical workflow, getting some data from the data catalog with dynamic pruning, applying some transformations, writing it with an optimized format, and then just committing that to a sink, which is just some S3 bucket, right, output. Nothing really that important. But now what I want to talk about is number one, how you can enable a Spark UI so you actually can set up for job configuration. So if you want to access the UI, what you can do is add job config. So up here, if we go to job config, E10. So what we can do is actually just customize this and add a job config field, and then pass in job_config to our job init. And here what we'll do, we'll enable a Spark UI. So instead of having to go through the command line interface, you can interact via a web UI, and depending on your preference, personally more of a CLI guy, but if you like interacting with Spark via their pretty mediocre UI, you can. But really cool here is that you can also have event logs and set those event logs to also go out to a different bucket. So you can ingest those event logs then from that S3 bucket to whatever your centralized monitoring stack is. And typically, you're going to be running Spark jobs or Glue jobs in conjunction with other workflows. So it's really nice in a lot of situations to have all those logs get consolidated somewhere. And then you can also do things like enable a continuous CloudWatch log as well. So all those logs will be sent to CloudWatch, which if you're using AWS, odds are you're probably using CloudWatch as well. And then you can also enable job insights, which will give you line level failure analysis if there is any failure in your operations as well. So always good configuration to have for any of your jobs that you're actually running. Make sure these are enabled. So that's how you can add some configurations to get more details from your logs and configure where you're setting your logs. But then how do you enable more advanced debugging workflows? So the first one I'll show you here, so call this advanced debug. is going to show you how you can get more information from your debugging logs and also have analysis performed automatically to figure out where the issues are coming from. So here, more advanced debugging workflow, we'll first have AWS Glue context. So assuming this is a function that you're going to run as part of a larger pipeline, you might want to define this as a separate function that gets pulled into pipelines, because that way you don't have to copy and paste all this code into all of your different ETL files. You can just have this advanced, this debugging function that you import into all the pipelines that need that debugging. And then we're also going to import logging for getting the logging information, interacting with the logger. This is going to allow us to get much more information around that context of the job that's happening. Then down here in this example, we're debugging some data skew issues. So here, getting the PySpark functions for column and count, and analyzing partition distribution, making sure that partition distribution is even, calculating the skew metrics, making sure there's no skewed partitions that might be crashing performance, and then if there is, alerting on exactly what those data skews are and what partitions are skewed, right? So not only detecting errors, but also narrowing them down so I, as a user, don't have to come in here and perform this analysis. It's all automated. And that's really the kind of workflows you want to have for your debugging as you're implementing this throughout your Glue pipelines. And then down here, you can see the way you would implement this in pipeline is just debug data skew, whatever data frame you're manipulating as part of a pipeline, and have it interact and go through this flow on demand as needed. Now, while issues with the data are a lot of cause of errors, you also want to think about workflows that can check and analyze the actual memory consumption and detect errors that might be occurring there. So let's see, if I add now, I'll show you how you can interact with the actual compute resources and develop an automated workflow for analyzing them and dealing with them, and to detect things like out-of-memory errors. And so here, what you do is you define a function like, here, handle memory issues, get that Glue context and large data and whatever data set you're interacting with. And here, we're going to enable bounded execution, max files per partition. So this is, just number one, making sure you can't go out of memory. So if you have large data sets that are having issues with, hey, it's going out of memory, this will just straight up not allow them to, and will cause them to, then get partitioned down into smaller operations. Also, you can dynamically choose worker type. So this is good if you have different buckets of workflows or files or size of files. You can say, hey, based on the size of that file, in this case, just 2 buckets, either smaller or greater than 100 gigabytes. But you can get more granular here and choose what type of worker is going to execute different workloads. So you're not using really large workers for every task. You're only using it for the tasks that need it, but you're not getting hit with those out-of-memory issues. Another thing you can do is optimize your JDBC reads, so making sure you're not reading in too much. Here, setting the fetch size is really the critical one, not fetching too many records at once, which will potentially overload a worker. And then creating dynamic frames from a smaller chunk of that, and then constantly adding to it over time rather than trying to bulk load everything at once is another good pattern to follow here to avoid those kind of out-of-memory issues you might run into. Now, another good function to have is, configuring that CloudWatch export. So let's create a function for that you can basically export from different points in the pipeline certain information to a CloudWatch dashboard, right? And this is where, any kind of custom metrics, right? You maybe want to export around, hey, what was the, size of this file or dimensions or, job name, right? Just, kind of generic alerts, right? Or just maybe an event stream to make sure that, things are going off as planned. And here we're just importing JSON and date time, and then choosing the CloudWatch metrics we're going to get. So getting it from our local Glue environment, right? So timestamp, the metric name unit, whatever can be whatever you want to define. And then here, getting the environment, getting the job name, and then dumping the metric logs into CloudWatch, right? And then having tracking those process metrics, emitting those custom metrics out to wherever location you want within CloudWatch, and then having those ingested there. And so you have, again, another way to monitor from different points of the pipeline, things like the data size generated, or maybe, hey, what was the result of this transformation and how quickly did it perform. Now, the last thing I want to show you how to do is how to implement a little bit of auto scaling. So here, there's a nice little tool where you can auto scale based on data processing units, which here, we're basically just calculating based on how complex is this job going to be. So you can pass in, the complexity of that query, and then say, hey, based on the complexity of that query and the amount of data, this needs to calculate the amount of data processing units, and you have this be X amount of compute, X amount of workers based to meet a certain workflow, right? So a nice little fun tool for just basically if you want to have even more dynamic generation of workers, or actual being able to size different workers based on different complexity and have it all happen dynamically. Really nice way to do that, where you kind of have different inputs and calculate it on the fly per job. And actually, fake out, I also want to show you guys a really cool error handling framework. So here, error handling framework.py. I'm going to basically set up a number of different errors types and ways to handle them, so that you can then use for different types of errors you might experience, that you don't just get a massive log file of just endless strings. It's more of a consolidator here. This is exactly what's happening, because that's how you want to handle debugging. Get really granular as quick as possible so you know how to fix that thing. So here we're first just creating a few different error types. So transient, data quality, permanent, and then just importing the type random and enum function, right? And then what we're going to do is, number one, set some exponential backoffs for our glue jobs. So common problem is, hey, error failed because it wasn't able to get data in time, right? Having an exponential backoff gives that data a little more time to arrive. Boom, really easy way to implement that. Then we can also classify the different errors based on what type of error type it is. So here, see, we're going to filter through the error message, go for, hey, is this a throttling exception? Is this a service unavailable? Is it a timeout? That means it's probably a transient error. If there is a data quality exception, a schema validation error, then it's a data quality issue. Otherwise, it might be some kind of permanent error. And this is where you can get granular and say, hey, what are the different errors I'm experiencing, and how can I classify them to make it easier for me to identify and fix whatever that it is, assign the right resource. And then handle with retry, so you can execute functions with that intelligent retry logic in it. So hey, for every attempt within that of that action, with that automatic retry built in, detect any errors and basically wrap it in an error handling mechanism that you can then hey, if something breaks, send it to the dead letter queue. If it's transient, just do a retry. Otherwise, it's a permanent error, fail it immediately. And then here, we're sending the failed records to the dead letter queue, because obviously you want to collect any failed data to see what happened there. You can see then writing that to the -3 dead letter location as well. And that is really all I have for you. No fake out this time. Just wanted to go through a number of different patterns that you can implement in Glue relatively easily to handle a lot of common issues and make it easier on yourself. So I hope you enjoyed this video. I hope you have a great rest of your day. Data Guy out.